that. Like we want zero extinction if you don't even know what you have. So that's always been something I've been really passionate about. And actually, I mean, just anecdotally with you, Ben and Joe, like I remember when in 2007, when we were in our PhDs, something called Encyclopedia of Life launched. And I remember it was sort of more of an aspirational thing, like it was really going to sort this out. And I got really excited about that. And I don't think Encyclopedia of Life really turned out the way I wanted it to be, but I got really excited about this idea of an outcome that's bigger than a publication, that's sort of a text thing with printed figures that exists in the record, but is static, and these sort of living, breathing technology tools. Then I went back to Stanford to do a postdoc and just got really interested. And I met my co-director, Kenichi Ueda, who actually started iNaturalist as a website 2 years before I met him. And then we sort of been running. I've been working with iNaturalist for over 10 years now. It's been fun.
Awesome. Thanks for sharing that background, Scott. I still remember you pulling up these old taxonomy books and just chillaxing to taxonomy. And it's like, wow, you are made of a different cloth. You love taxonomy so much. You're like, yeah, this is great. So I'm really excited to see you be doing this. And welcome, Natasha. Dr. Stavros is coming from the Boulders Earth Lab, and we're really delighted to have you here, Natasha. Thank you so much. Also with us is Joe Sexton at TerraPulse and Scott Laurie at iNaturalist. And maybe if you feel comfortable going for it, you could just introduce yourself and how you use machine learning, and maybe how you ended up where you're at doing this.
Who do you want to go first?
Oh, Natasha, let's start with you. Scott was just kind of wrapping up his piece, and I'm just really pleased you could join us. Thank you so much for taking time.
And real quick, Natasha, I think I might be watching you on my other monitor editing this manuscript.
Probably if you had seen it this weekend, you would have been, it was a bit of a heavy hand, I have to say, but don't invite me unless you want like a deep edit. But so I guess, hi everyone in the class, it's so nice to meet you. I work at the University of Colorado Boulder, which has a cooperative agreement with NOAA for a research institute called this is a mouthful, Cooperative Institute for Research in Environmental Sciences. The shorthand is CIRES. And I'm research faculty, so I don't actually teach any courses. And within that institute, I'm the director of the Earth Lab Analytics Hub. So my particular focus is on helping researchers of all experience levels harness the data revolution by providing services such as data collection, data curation, data tools, novel data analytics, bringing in the cutting edge data science, and consulting on scalable scientific compute. So all of those things sort of fall within my purview. And I am going to show, if it's okay, just I can't show anything. I do have like
I can turn it on.
Okay.
I wasn't asking folks to prepare anything, so.
Oh, I just have a pre-baked slide that I think I can.
Sure, yeah. Okay, hopefully now you can share.
Yeah, perfect. Okay. So if I do this, can you see this in big mode?
Yep.
Yes. Okay. So where I use and where my team uses machine learning is really in this sort of framework. And so when we think about like what innovation is changing the way that we live in the world. So a lot of people think of innovation as like a single tool, like, oh, if I just create this little golden tool, I'll get rich quick. Right? That's how Silicon Valley tends to think about it. But if you actually look at what innovation is, it's sort of systematic change in the way that we live in the world, right? Uber was not innovative because it was an app. Google was innovative because it changed the policies for getting people from the airport and how we interact with taxi drivers, right? That's what innovation is. And so how do we actually innovate in this world? Well, we have to kind of step back from thinking about the specific tools we use, like machine learning, which is extremely valuable. And we have to think about, like, how do we systematically change? And that's kind of starts here in, this is actually a framework I published back in 2022, and I actually just launched a 12-minute masterclass, which I can put the link to in the chat later. But we have to start with thinking about it from wisdom, which is actually a pretty novel way to think about it, because, and this is actually how machine learning ties to AI. Because most people, when they talk about what you see here, this is the knowledge hierarchy. Most people, when they talk about it, they actually start with data. And then, of course, the next step is machine learning. But actually, if you want to do machine learning in a meaningful way, you have to start with, what are the decisions and the things and the prescriptive analytics that we would need to provide to change the way that we live in the world? And from that, you can get down into predictive analytics, which is about potential scenarios. And that's really where artificial intelligence is. And then if we take a step further down and we say, okay, but how do we even get to that point? That's where machine learning fits in, right? Because machine learning allows us to look at the patterns of all of this data in the first place, that we don't have enough workforce to possibly even begin to look at ourselves. So we're sort of democratizing, or we're opening up the door to allow machines to help us in that space, which is kind of where automation came from in the first place, right? Automation came from back in the day, the industrial era, when we had assembly lines. It was too hard, it was too much work, no one wanted to do the work, so we automated those processes. Now AI is about automating not just pattern recognition through machine learning, but synthesis and interpretation, which is where artificial intelligence is. It's the next step up. But we only want to do AI in the means that it helps us to change the way that we do things. And so just to kind of wrap it up, where I'm at right now and what my team works on is, how in this changing world, how do we harness the data revolution to help us inform in a very strategic and systematic way what we should be doing to build more resilient futures to that change, whether it's climate change, population growth, urban expansion, biodiversity loss. So we hit all of those topics at Earth Lab. So this is what I do. And then how I got here is a very convoluted route. So I would just say that I challenge all of you to think about things not from like a career track or some like siloed discipline that is predefined, or a track that's predefined for you, but to think about each of your experiences as an opportunity to get a different set of skills that you can then put together to build into a unique experience and what we would call a career. So a career is something you look back on. It's not something you predefine. So for me, I just had a collection of experiences that helped me to work with decision makers, from policy to land managers. So that's kind of where I really understand the wisdom world and the business operations, down through working with actual, analytics and AI and machine learning. So that, and then I worked with NASA, which is about data collection. So what are the different things that we have? So that's my story in a nutshell.
Awesome. Thank you so much, Natasha. I love the WICKED acronym and the sort of Bostonian terminology there. And actually my advisor is a big fan of that sort of paradigm of going just from data to actual wisdom or decision. So even it ended up as a part of the title of my dissertation, was from data to decisions, and how we get there. So yeah, that's awesome.
And I think the argument there is to actually flip that on its head and start with wisdom. What are the decisions to work backwards to how we work with data? And that knowledge hierarchy is from like the 70s. It's super, super well known. And I just want to let you know that I've heard this a lot, the Bostonian reference for wicked. And just so you know, in complex systems science, wicked problems are, it's an actual technical term. to mean a problem that has no one authority. So there's no one group or entity that can fix that problem. So it's like obesity, opioid epidemic, systemic racism, climate change, right? Like no one person can just say, here's what we're going to do and we're going to solve the problem, right? It involves too many people with too many different requirements. So it's kind of a play on words there.
I like it. And when you mentioned going back the other way, it reminded me of this awesome term that I heard from you, Scott, at one point with dark spots, understanding like, okay, here's where we have gaps in where species are distributed, but here's where, given a species distribution model, we might expect them to be there. So how can we gamify then the citizen scientists to go and collect more data so we can actually refine our models? Did I summarize your dark spots instead of your hot spots notion?
Yeah, I mean, certainly, yeah, in terms of, I think what I like about the models is, or using machine learning also, is it really defines learning. I think one of the things we struggle with naturals is just, we're just generating lots of data. Any data can be good, and that's true. We want a big tent, and we don't want to say just this and this, any data is great. But when we have specific models we're trying to train, you can say, this is information that will really teach this model, and this is information that, is not. And I think that's super useful for a certain set of valuation around what data is important and what kind of behaviors are important. Not to say that we want to only focus on models that we're building.
Yeah, awesome. And Joe, can we take it to you to tell us how you what if you were to describe your path? I'm sure you could come up with some colorful terminology.
I'll try to keep it clean. Yeah, so I'm an ecologist, bachelor's in wildlife ecology from the University of Florida. I had minors in both zoology and forestry, but I did a research internship at a fire ecology research station in 1998, which was a big El Nino year. So there were parts of Florida that burned. Well, I think it was something like the national forest area of Florida burned twice in 1998 in Florida. It was some ridiculous factoid like that. But my job was to cruise timber in the Florida Panhandle in July with a gigantic GPS unit with camcorder batteries as the power supply and wearing a backpack and snake chaps. It was the first time I saw a GPS unit. It was also the first time I saw GIS, and it was also the first time I saw a satellite image. And so the juxtaposition of wearing snake chaps, having poison ivy between my fingers because you have to untie your shoes at the end of the day, and then seeing something that was like, wait, this is a better way to do that. And I taught myself GIS in the lab after cruising timber all day long. And I went back to my department chair and said, I want to change the focus of my minor to do GIS and satellite remote sensing. And he's like, those aren't words to me. I don't know what you mean. And I was like, okay, he's like, we have a brand. Your next coursework is feller buncher, timber operations, forest management, planning, and operations. I'm like, okay. I dropped the minor, went over to the geography department, and found a grad student to sign off on my papers to do an independent study. And I built a fire database for the University of Florida's teaching laboratory out in the Sandhills. I handed it to my department chair at my graduation barbecue. It's like on a zip drive. I was like, this will be useful. They used it 15 years later. So then I graduated, I went to Utah. I wanted to get as far culturally, ecologically, everything from Florida as I possibly could and still speak English. And they had a mountain of Landsat data. At that time, Landsat images were $2,000 a piece. You basically had to go to the data. I got a fellowship to work at Utah State. It took me 4 years to get a master's degree, but I took a bunch of computer science and statistics classes with like one of the developers of Random Forests, and multivariate statistics on my ecology side, statistics department classes, computer science department classes, put them all together with snowboarding, whitewater rafting, fly fishing, kayaking, and on the weekends. And as I was finishing that, the job of that degree was, I went in there to study fire. My advisor got a job with the 2000 Winter Olympics with prescribed avalanches, and I never saw him. So I moved over to the RSGIS lab and did species distribution modeling. The job of that, or the task of that job was to make maps. Then I moved to Duke. My objective there was to make maps backward through time consistently so that we can do time series to make data cubes of space and time to look at land cover, vegetation change, gradients, that sort of thing. Finished that. And as I was finishing that, got a call from the team at NASA that was building the world's first Landsat-based forest change data set, the Global Forest Coverage Change Project. Went become a postdoc at NASA, moved over to the University of Maryland to become research faculty. My algorithms that I developed in my PhD became the algorithms that created the NASA Global Forest Cover Change Project. We published that data in 2013. We started the company in 2014. We quit our jobs in 2019. And here we are. And today, Scott, to your point of like thinking about learning, today I came out of this meeting into a meeting where we were comparing spaceborne laser JEDI measurements to small footprint LiDAR, trying to figure out which of them is truth. Like before I looked at the spaceborne measurements, the airborne measurements were my truth. They're like asking me, they're showing me scatter plots and density plots and asking me to change gods. So yeah, like we're like, and to your point, Natasha, that like in order to make these changes for like these tactical changes of building the killer app, building the killer data set, getting it out to like one application, you're trying to change more than just like an instance. You're trying to change something systemically. And then to Scott, you have to revisit what you even think of as learning in order to make a model of it for a machine or an artificial intelligence.
Awesome. Wow. Well, I'm wondering if one of the next questions more for open discussion, so feel free to jump in here, is just like, what are some of these breakthrough technologies that there's obviously been a lot of trends, and what is, as far as for folks interested going deeper into the machine learning and some of these contextual questions, and kind of what do you guys think are some breakthrough technologies and some trends to keep an eye out for making the most impact and having the most fun? Joe?
That's Ben.
Yeah, Joe, go ahead. You're still on screen. So,
okay. Let's see. So like what to look out for. There's so much. Like what's coming? Geez, that's hard. Like give me specifics. So for us, I'll only speak for us. Like the things that are really cool for us, radar's letting us see through clouds. LiDAR is giving us three-dimensional structure, like giant data sources of globally distributed data are allowing us to fill in the map everywhere where we don't have the reference data. We use data from iNaturalist in our science. Like it's everything's being connected, is hosted on the cloud, being connected through API. And so we're not in this sort of feed forward value mining toward trash economy. It's a network of replenished information. So TerraPulse takes data from satellites, data from other sources, like mashes them up. It's and it's sort of like DJ culture. Like, when was the last time you listened? If you guys go to clubs or listen to hip hop or anything, like, when was the last time you listened to a song that was an original, 100% original piece of music? It's all sampled and resampled and resampled, and it just sort of grows. And the major players in the music industry are the ones with the most connections, right? Like their tracks get sampled more than other tracks. It's about product generation, unique contribution, and then distribution, and making sure people get your content. So yeah, there's the technical aspect, and then there's like the growing network industry where it's not just like we're taking stuff out of the ground and extracting value and making products until we have garbage and heat. It's a positive sum economy, which is crazy, right? We don't have competition models for positive sum environments.
I like that. Yeah, super fun instead of zero sum. And the DJ analogy, how often can you get resampled with your data? It's a more colorful way of saying data discovery and sharing. But Natasha, I see you've got your hand up, so yeah, jump on in.
Yeah, I think I would expand on that. So I think everything Joe just said is really great, and like NASA and European Space Agency have really opened up free data, satellite data of lots of like new and novel measurements. In that space, I would encourage, if you want to work with that data, to find someone who's like a specialist in that data. But this is true for anything. And I would step back from actually just thinking about satellite data. And I would say that one of like the really big cutting edge things, especially in the world of machine learning, is Internet of Things. So really recognizing the value of like lots of diverse data sets that are coming from just unknown sources. So like Twitter, social media, sensors that people have like available through like Alexa, like if you can even get your hands on that data. But like Zillow, for example, is another one. Like Earth Lab works with Zillow data, right? So there's data being collected all over everywhere. And so really broadening and expanding your mind to think about the availability of different data sets. And, you know, just to feed on this, like I love iNaturalist. I'm like one of the biggest fans of iNaturalist. I tell everybody, I'm like on Nextdoor all the time. I'm like, take a picture on iNaturalist, put it on iNaturalist. So citizen science, I think, is another area. So there's Internet of Things, which is like the network of how all this data is connected and the diversity of that data. And then there's, you know, citizen science, I think, is really cutting edge and something to look out for. There's iNaturalist. There's other variants of that, like eDNA networks that are going and collecting DNA samples. You see that with 23andMe is an example of that, that answer and ask all kinds of interesting environmental questions. And then I really think what I hear a lot from the powers that be, that for whom I answer to, is sort of this cutting edge world of like gamification and what they're calling digital twins. So this idea that like, we only have one Earth. We cannot go and just experiment on Earth, you know, without extreme heavy costs for us, but we have this world of data from Internet of Things. So could we build digital twins, kind of like Sim? Like if you remember Sim City or Sims, I don't know if I'm dating myself, but like, can you just play out different scenarios of what would happen? And this is really where AI comes in and the machine learning that's like powering and behind all of that. So for me, those are like from the data to the data collection to the analytics behind it, the key driving areas of where to look out for.
Internet of Things and simulations, Sim City for the planet. I love it. Scott, does this prompt any other thoughts from you too? You at least, you have a more recognized fan base for iNat.
Yeah, no, thanks, Natasha. I guess one thing that hasn't been brought up that we think a lot about is just ways of keeping these systems not circular. I think that, you know, and it gets back to kind of misinformation and things like this. Like, how do you how do you use these? Well, here's a good example. Like, so we're really interested in using AI to surface weird stuff, like problems, right? But like we're also using that data to teach the AI what's normal and what's weird. So like this tricky thing with, in order to teach the AI, you really want it to go through a really rigorous kind of like, in our case, it's humans teaching the AI, but you also then want that AI to be a tool to help human scale things. So, I mean, just a good example, like one of the things we're really interested in is like a species pops up in a place that's just really unfamiliar. Maybe it's a new weed, maybe it's some sort of weird invasive species or a new population that we hadn't known about before. And if that pops up, it's probably an error, right? So the AI could say, hey, this is an error and let's correct that. Or you could say, this is something really interesting. Let's get this in front of the eyes of a human to like verify, make sure this is weird. And it's really hard to tease those things apart. So like, how do you insert AIs in this kind of like scalability thing that we were talking about? Whereas also making sure that you don't just ignore all the weird stuff because that's unusual and the model's like, can't be this, it's unusual. Or just like have it just not help with scaling at all and just shunt these things onto humans and not save you any time, or even worse, learn from these errors and become wrong, you know? So we're just struggling with how to like benefit from the scalability aspect of AI to help streamline this stuff, whereas still really needing this stuff to get in front of human eyes for it to be kind of vetted, which I think is kind of interesting.
Yeah, because at some point, one of the last modules that we had actually was on ethics in AI, and just looking at representation and how, for instance, if you have a observation that for a given species, then you're going to have a weird anomalous outlier. It's not going to be representative. Yeah, that's a good point. I guess I'm wondering, just generally, what do you think you're kind of alluding to this, Scott, with the problems with the data going in, potentially training it in the wrong ways, but what are some of these pitfalls that befall the budding machine learning engineer or scientist in the environmental space? And I don't know if Scott, if you want to elaborate on what you were just saying with like, what are the common problems that you're encountering?
Scott, you're muted.
Sorry. I mean, one thing that's been interesting for me is I think the background I had in grad school was much more about like processes, and your models were all about process models and like really thinking about what the process was that you were trying to model. And for better or for worse, I mean, it's really interesting that these machine learning things are complete black boxes. I mean, no one has a clue how they work. And they're really just about, I mean, it literally is the gazillion monkeys on a gazillion keyboards just typing away, and eventually you get them right. So it's all about just lots and lots of data and lots and lots of really good machine computing power, which is getting hard, especially, we were really hit by that with the supply chain. We got issues this year, we got a bunch of grants from Amazon to use these new machines with these new GPUs, and they just didn't have any because they're probably all being used for like Bitcoin mining or something. So it's hard to get these machines that are capable of doing this stuff at scale. And then also a validation pipeline is really, really, really important. While you don't have to really understand the process, you have to have a validation pipeline. And that's been really easy for us with this kind of species identification problem. Like, we know this is a photo of this species, so we can tell if our model does well or not. But we're having a really hard time with that with distribution modeling. Like, it's really hard. Our models can say, we think this tree occurs here, but we don't, it's really hard to get a validation data set that says, no, this tree doesn't occur here. You know, so like, these models can only work if you have the data to train them, the machine computing power to train them, and also a validation protocol. So the validation is really, really important.
Mm-hmm. Awesome. Yeah. Let's see, Joe or Natasha, do you have any other thoughts about, some of these common pitfalls, or have you encountered some of these issues, especially in the like satellite imagery world with, what is truth? You alluded to that earlier, Joe, and it's a constant enigma.
I like my paper that has been in review. I think my lowest cited paper that has been in review, the longest battle for the longest amount of time, it was actually rejected by reviewer number 2, but his review was so characteristic. I called him on the phone and I was like, redacted, this is Joe Sexton, you just rejected my paper. I'm right, and I want to convince you of that. He said I didn't. It took 18 months for me to convince him, and we went offline. The editor of the journal did not know. We had 18 months on this like Darth Vader battle of like, what is truth, what is reality. He finally relented, and there is a paragraph in my paper with the words propagation of uncertainty in the title, where this person made me write out definitions for truth, error, uncertainty, all these things. And like it's, and actually in our product meeting this morning, we had like we had a discussion on the different, what probability means. Like if you're mapping wildfire probability and a wildfire occurred in that year, like did the wildfire exceed the probability, or was the probability by definition 1? Right? So if you're retrospectively mapping wildfire probability, like was the wildfire probability what you modeled it as, or do you you burn in 1 when given the uncertainty of the measurement? Anyway, so yeah, it like even the philosophers, having had to go and do the book work on it, even the philosophers are not settled on these meanings. And it just requires individual human beings making decisions on what our personal philosophy is. And that philosophy is going to be subject to market evolutionary constraints, as well as practical constraints, as well as ontological, epistemological constraints, right? So it's kind of like you can go completely down the rabbit hole for your entire career, 18 months on one poorly cited manuscript, or you can just sort of do your best, stand and deliver, and recognize that like even the experts don't have an answer. Do your best, but like present your results. And I mean, the big thing that like the crux of my algorithm that made the NASA global forest cover change, we mapped our uncertainty. That's it. Like we made maps of uncertainty where everybody else was producing map, and then doing change detection between maps where they didn't map their uncertainty, and they had all kinds of commission and omission errors because they didn't actually do a signal to noise ratio test. Stupid. But the scary thing was we were just like, okay, like we're going in here and we're going to make a map of our RMSE, and people are going to like attack us like a swarm of hornets because we're showing what we don't know. But like we kind of stood back and we're like, that's science, right? Do it. And we did it. And then we just explained, well, there's your map. This is probably like speaking to Scott, like there's your map of what we know we don't know, right? So go there. Don't try to map forest in the center of the Amazon. We're good. The center of the Sahara, we're good. We don't need to spend any more resources. So it is actually like, it enables us to be a functioning business that stays in business and doesn't reach a financial extinction event every couple months, because we allocate resources based on our uncertainty. It provides your guides of what to discover next.
I'm glad you brought up uncertainty. The master's students have a capstone project that they just presented for the first time for faculty review. And I would say that the biggest consistent question that was being asked was, well, show me the uncertainty and what does that look like? So, and that really, like, especially when we're talking about the reuse of these products and how there's uncertainty throughout the stage of, say, initial observation, and then maybe that gets modeled, and then you're modeling on top of another model. that there's this cascade of uncertainty, and how that gets incorporated is kind of also, you know, sometimes challenging. But Natasha, you've had your hand up, so I'd love to hear your thoughts.
Yeah, I just want to expand on that. So there's two things I want to say. I'm going to say them so that if I forget the second thing, you can remind me. The first thing is about systematic evaluation of uncertainty. So I want to talk about that. And then the second thing I want to talk about is the premise of science and the scientific method as a basis and how it ties back. So the first thing I want to say is about sort of systematic evaluation of what we call truth, right? So ecologists have this problem all the time, going out in the field, trekking up mountains, carrying equipment. It's very, very time consuming. And so we're just limited. You know, Joe mentioned this, we're practically limited in the amount of time and energy that we can spend. And so they've actually developed really great methods in statistics for saying, how do you sort of systematically evaluate across something that we would call confounding factors or confounding variables. And so when Joe's talking about creating a global product for Jedi, you know, the team is asking themselves, okay, well, what are the variations in forest structures and ecosystem structures? And how do I make sure that I have enough sites that I can at least compare to that represent across that range of variability, right? So one question to ask yourself is, what are the different factors and how are they varying? And am I creating a systematic design in my validation to be able to look across those? And if not, am I being transparent about where I can and cannot make inference because there's something that I may not be capturing, right? So that's, and that's actually a problem that we saw at NASA. I used to work with like Nobel laureates designing mission satellites. And one of the most common challenges that they had was what we would call data sufficiency. So they are like, oh, well, we're mapping the whole world, so we have lots of data, we're good, right? And we're like, no, wait, do you actually have enough data across the right gradients to be able to draw robust conclusions? And so that's kind of the thing that you have to ask yourself when you're looking at the data set that's going in to train your model. The second thing I want to talk about is I want to actually step back and say, the scientific, you know, what is science? Well, it's a method. It's a method of critical thinking. And if you actually, you know, we've all seen it, right? Hypothesis, methods, results, discussion, conclusion. You saw it from your 5th grade teachers, 6th grade, high school, and now still in your college labs. And you're like, okay, I'm following this formula. But if you actually step back and ask yourself, okay, what is a hypothesis? That's actually I took an entire course on what a hypothesis is, like 3 months. What is a hypothesis? And the most important thing, and there are books written on this, the most important thing to remember is that no hypothesis can be proven true. Okay, we cannot say that something is definitively true. What we can do is we can say, we can't not prove it. And so this is really important to bring it back to your ethical course that you had, because the more ways that we ask and say, well, we can't prove it's not true because I tried it from this perspective, and I tried it from this perspective, and I tried it from this perspective, and I tried it from this perspective. That's how we build confidence that it might be true, right? Now that's like mind blown, right? Like I can't ever say something's true, but I might be able to be confident that something is true. So this is why it's so important when we think about sampling across our range of variability is, are we actually building our study and our analytics around the variation of ways that this could be interpreted, not just across the data gradients and variation, but am I testing across the different ways that this could be interpreted? Because that's how I build confidence in what I have. So there's, and this is really important in the general context, right? There's uncertainty, there's confidence, and these are two separate things. They help each other, but they're not one and the same. So those are my two sort of take-home points from the comments from Scott and Joe.
I appreciate that. That's awesome. Yeah, the fundamentals of the scientific method, and the fact that even Newton was wrong, and then it turns out Einstein was wrong, and I'm sure that the quantum physicists are going to be wrong in some future date as well. So, well, I'd love to, we're going to open it up to questions in just a couple minutes from the students. I'm sure they've got a bunch of really insightful ones. But before we do, I'm wondering if, do you have, what advice would you have for these guys going, they're finishing a master's in environmental data science, they're really keen to in conservation efforts, and they're trying to change the world for the better. What advice might you want to offer them as they move forward into the world, and prospects for job markets, or what to look out for, and even just your idea of academia versus for-profit versus nonprofit versus government. Yeah, and Natasha, you're still on screen, so maybe we'll just go with you.
Oh, well, so I would say, like, I said this before, right? A career is something you look back on. It's not something you plan. And I was really struggling with this for a long time because I'm a Jane of all trades. And I have a little bit of ADHD. I cannot focus on one thing. I like to do it all. It all is exciting to me. And so that was really hard for me because I was like, where do I fit? I don't fit anywhere. And someone once told me, well, if it takes 10,000 hours to be an expert at something, that's 5 full-time work years. And assume you have to work from 25 to 65, that's 40 years. So you have 8 different times that you can be an expert in your life. So I think the best advice is just to think about each time, what can you become an expert in? What skills are you going to get? And just know that just because you make a decision today doesn't mean you can't change that decision in the future, because you can build things on each other. When I did my degrees, everybody was like, how does math and computer science relate with this other, with environmental sustainability? And then how does it relate with climate and fire? And then how does it relate with remote sensing? And then how does it relate with information technologies? And before you know it, I have a career. And environmental data science is like this new discipline. So sometimes the world isn't caught up with where you're at. So listen to yourself and follow that. With respect to job prospects, I would say a really good way to think about this is that there's 4 major roles that make our system work, right? There's private sector, who are the doers. And they do things. And now whether they usually do them for shareholders, right? For a profit. So they're very business motivated, but they get stuff done, right? That's your SpaceX. They build rockets, or aerospace, right? They build certain parts. Then you've got nonprofits. They're also doers, but they do things for the good of the thing that they're doing it for, not for the money, right? So they're just motivated slightly different, but both doers. Then you've got academics. They're the thinkers. They're the ones who, as Joe mentioned, will sit there for 18 months and go back and forth and what's truth? And do we have any space here, right? And they're really important because they hold the doers accountable. They go and say, is this really doing what you're saying it's doing? But really, is it? Right? So they hold people accountable, and they ground us in. And then there's government. And government, their role is to coordinate the doers and the accountability experts and make sure that we're providing a service for all. So it's really a matter of where do you want to fit on that spectrum? And I will say that at some point you will have to make a decision, because the incentive programs in each of these thrusts are different. And so it will be very hard for you to pivot, but you don't have to make that decision today. I've pivoted multiple times. And dragged my feet. And so, remember that there's always these, think of it in 5-year pivot points. You can pivot every 5 years, just get something out of the 5 years that you dedicated to it.
Wow, that's awesome framework. I love it. The doers and thinkers and understanding their incentives. Yeah, well described. Thank you, Natasha. Scott or Joe, do you want to share some advice? Or Scott's muted, so we'll go with
go ahead, Joe. Me?
Yeah.
I'll give yeah, I mean, I think iNaturalist is is a weird thing because it's just such a unviable business. You know, I mean, it's like we're essentially trying to. It's just so kind of naive and utopian that like you can get this thing that no one really cares about, which is nature and critters, and get enough people to fund this pretty expensive site that also wants to be like super anti-commercial and like anti-for-profit. And you know, it's been tough. It's been really tough. And I think we wouldn't have these problems if we chose almost anything other than nature. But I mean, I think the way we've survived with INAT, which is a bit of a unique thing, is just by really focusing and really staying, trying to keep narrow. You know, we're trying to do this one thing, which is, you know, connect people to nature, and we're trying to do it better than everybody else. And we've resisted all the kind of like other avenues for doing different kinds of stuff or doing, you know, and I'm not sure that's right. I think time will tell, but it is, and I also just think how privileged I am to have the support. You know, I just feel like I've had people opening doors for me left and right. And I don't think there's any way we could have done INAT if those doors were being slammed. And it just makes me realize how unequal the world is too. And we're very grateful for having had this opportunity.
Yeah. I love how you're like promoting the unviable business. The honesty and the hustle that is involved is no joke. So, and Joe, you're also you got the TerraPulse business. So, you know, what's and coming from an academic background also.
Yeah. So I don't think I've worked, not since like high school have I worked in a nonprofit, but I've got the .edu, I've got the .gov, and now I've got the .com. For me, those lines are a little blurrier. I mean, since full cost accounting in the federal government, the government is federal government especially is being run more increasingly like a consulting agency. That's like, and I don't care if you, that's not a normative statement. That's a positive statement. That's what is happening. Nonprofits, I think that those are like, I definitely, those categorization resonate with me. But being in the DC area where the rents are high, the nonprofits have boards to serve, the government have funding streams to serve. Like this whole thing runs. It does. It runs on passion, mission, and money. It does. But to like try to like turn this into advice. One, the big picture is everyone sitting in that green lit room is in an excellent position right now. Like dig who you are and what you've got in front of you and who you've got teaching you. Like the thing that you're learning was not a thing when the people that are giving you advice were where you are, right? So if we were to, and I don't think the three of us do, if we were to imagine like we are somehow these special geniuses with the like God whispering in our ear and we got it, that's not what happened. We did what we were passionate about and suddenly the world moved and we became valuable. Like, holy shit. Like we got really lucky. You are even more lucky because we had to wait for ourselves. You're catching the wave as it's cresting. You're paddled out, you're in the right position, the wave's coming up, Ben's sort of pointing you onto it, and you're ready to go. So you have all, and the best freedom in the world is not financial freedom, it's not academic freedom, it's unqualified freedom. Like take all the adjectives out and the term gets bigger. You, because of your position, you have the freedom to make mistakes. And so that's like the best freedom there is, like mistakes with little consequence, because if you mess up, you can actually, like, your skills are in such demand that you can move down the street and someone like, yeah, my little brother has a master's in economics. He's interviewing with Meta next week, right? Like, because he's moving to Bangladesh, because right, it's like you can work remotely, you can do so much shit that we could not do. And so like how to turn that into like action is really like figure out what your skills are, who you are, and what you want to do. And then find people that do the other parts. I am like the biggest cards face up hippie like in the private sector. What I want to do is I want to map the entire planet through space and time in every variable possible and put that information into anybody's hands because I just love sharing what I do. My business partner is like, he does the accounting, he does the finances, he talks to the investors. I just get to be like the space cadet who sort of has a weird ability to look at maps and say, I think you're doing, you've calibrated your blue band wrong. So like get who you are. Like the old lines between edu, org, gov, and com are blurring. There are investors out there that want to save the world. They need really to be told like how and what that actually means. The sky's wide open. And so focus on what you want to do, make sure you're good at it. And there's certainly something that you're already good at in that space. And then if you're not the profit driven person, they're all over the place. Like they're like, that's actually most of the world. You got to get outside of the tower and outside of the beltway if you're in, if you're going to the DC area, and like it's out there.
Awesome. Really inspiring words. Thank you so much, Joe. I love it. Before we end the surf sesh, catching the wave, I'd love to open it up to questions. Sorry, guys, I should have used the same Zoom link so you could all just add into the chat. But anybody want to kick off with a question? Yeah.
Yeah, thank you so much. Like really inspirational words from all of you. How would you, because all of us, or many of us, have a background in environmental science or biology or just earth science. How would you say that you used your backgrounds in those fields as an asset for using machine learning? And how would you say that that's almost like a positive for us going into, say, like a job that requires machine learning versus someone that might be an expert in that field but doesn't have that like kind of passion driving like how to better use that to help the various issues that we're dealing with in the world?
Yeah, Natasha. Yeah.
Well, first of all, like remember that machine learning is just a tool and it's really useless without a purpose. So your domain expertise for the purpose of that is really invaluable. And then second, if you wanted to go more down the quantitative sort of doer route, which there are many ways to do, you could go collect field data, right? Like as Joe was just saying, you could be more on the business side. But I would say that like I used my ecology background doing remote sensing for NASA, not as an ecologist, but to help them with their calibration and validation sampling design, because I knew how to think across gradients of variation and how to set that up in a meaningful way. And so that was a way that I used the skill that I learned to help with the slightly different application. So those are sort of two ways. Is one, you have domain expertise and that's hugely valuable. And then also step back and say, what are the skills? What are the tools in my toolbox that I have available to me? And how might I be able to use those tools in different situations, right? Like a hammer is still a useful tool in many different approaches. Now, you don't want to use a hammer on a screw, but you can still use a hammer to build a deck. You can use it to build furniture. You can use it in, to put stakes in the ground doing field work, right? Like a hammer is still a useful tool for multiple applications. So think about it through those two lenses.
That's great. Thank you, Natasha. Do you guys have anything else to add, or before we try to field another question?
I would add to that and say, there's no perfect organism, right? Except the xenomorphs in the Alien series. Those are the perfect organisms. But I mean, that's what they're for. That's sort of the ecology in that movie. And what happens? They destroy everything and have to wait 1,000 years for somebody else to show up on their planet. There is no perfect organism, and you will, wherever you live in the world, you will have junky neighbors and you'll have rich neighbors. You're always between two other groups that are better than what you do, better than you at what you do, and worse than what you do. Like, find those synergies. And if you lean more on, I was the computer science stats guy until I met Min Fang, my co-founder, and then I'm like, I'm out. Like, this guy is nuts. And now I'm an ecologist again, right? Sweet. Like, that's kind of what I wanted to do in the first place. You're like, you kind of like follow the groove, and you can't control it so much. Get a job, like, go hard at it, throw everything you've got at it, but recognize that the class you're in is a technical class. You having the subject matter expertise in coastal, in terrestrial, in fire, in urban, whatever your domain of interest is a multiplier, because without that, you're competing against Eastern Europe, Asia. Every computer science, every data scientist on the earth and really on the cloud is your competitor. When you differentiate yourself, you specialize in a subject, now you're unique. There's a danger in becoming unique, and everybody kind of wants to always be the generalist that can do everything. And there's sort of like a fear of missing out tendency against sort of saying, like, I'm an ecologist, but like, once I met Saurabh, who does like big data architecture, Amazon cloud architecture, and Min, who can like scale any idea that I've ever come up with, it works better. And your ability to execute on one and advise on another, it will be your position then.
Love it. Scott, do you have anything else to add, or should we try to field one quick question?
I mean, happy to maybe just echo what has been said, jump to another question.
Yeah. Are you done? Okay. Another question.
This message is for Scott, and it's not machine learning, but it's the speaking to what is truth that y'all were discussing earlier. And I was curious on how iNaturalist decides what's the final authority on species and common names. For example, on iNaturalist, the Mexican feathergrass is listed under the genus Nacella. And in California, the authority, the Jepson manual, has it under Stipa, but the manual of flowering plants in Hawaii has it listed under Nacella.
Yeah, I mean, taxonomy,
That's a really good
the taxonomy is a human construct, right? And like, so yeah, and we try to just use external authorities when we can. And those have to be global authorities. So for plants, it's Q, which is trying to do this. I mean, Q is trying to bring plant community from around the world together to come up with a global consensus list. And we're not trying to do that. We're trying to like build on a taxonomy to get people outside documenting things and learning. So we try as best we can to like shunt those decisions out. But, you know, it's a constant thing on iNat where people try to, you know, have those arguments on iNat as well. But, you know, I think, yeah, I mean, I think more generally, it's one of the things with iNat is how do you build the structure where every part is moving, you know? And so like the taxonomy is moving, the community is moving, everything's moving, and keep it working. It's really hard. Yeah, for sure.
All right. Well, I think that we're at time, and I want to thank you all so much for generously sharing your time and thoughts and energy to advise this class. And I'll definitely want to stay in touch, and I'm really looking forward to seeing what they do next in the world. And these are really inspiring words. So Thank you guys. Let's give them a big round. All right. Well, enjoy the rest of your Monday, and thanks so much for joining, y'all. Talk soon.
Good seeing you,
Thanks,
man.
everybody.
Scott,
Yeah.
good
Bye,
seeing you.
guys.
Natasha.
Yeah. Awesome. Cheers, guys.
Bye.
All right. Wow. That is kind of trippy. Yeah. I don't know. Yeah, it's really interesting. So, let's see. Yeah, super festive. I guess that I just wanted to also mention, there's some good questions on Slack about the group project presentation. So I look forward to seeing what you guys have to share on Wednesday. A max of 10 minutes. We'll shoot for 8 minutes per group, and then a couple minutes for questions. And anybody in your group can, present whoever you feel is most comfortable. But then everybody should be available for the questions, and with preference to those who did not present. And then I got through the grading for the lab one, and my computer died on Friday, or actually Thursday. And so unfortunately, the hard drive is gone, so that the video from last Wednesday is gone, and I've been playing catch up. But yeah, so back up your stuff, make sure that everything is getting backed up, because you never know. Like your computer too could decide to expire the month after your 3-year Apple Care warranty expired too, and you just can't see these things coming. But let's see. Do we have other questions or comments about our last day, which is Wednesday? So, and I'm going to kick around for the office hours afterward, and we can go over anything with your group projects or other questions you have too. But thanks so much for your attention with this crew. I thought I just knew that Joe especially is going to be good with the little zinger phraseologies. So he came through on that front, and yeah, Scott and Natasha were fantastic. So I feel very lucky to have them. So all right, great. Well, thanks so much, and we'll pick it up again on Wednesday.